Hello Algebra 2 students, this is your Unit 2 review. On page 1 we're going to start by factoring. Anytime you need to factor, you always want to look first to see if there's a greatest common factor to take out. So looking at problem 1, I have 3x squared, 7x, and 2. I don't see a common factor. In B, I see x squared, 4x, 12. I don't see a common factor. But when I get to C, I do see a common factor, and I like to look at all of the factoring problems in advance to be sure I don't forget to look for that common factor. So in C, I can see that 3x squared and 48 can both be divided by 3. So I'm going to start by factoring that 3 out as a common factor. And then 3 times x squared would give me the 3x squared, and 3 times a negative 16 would give me the negative 48. And now I can see that I still have the difference of squares left inside the parentheses, so I can factor this. Basically, I'm looking for the two numbers that multiply to negative 16 and add to 0 because I don't have a middle term here. So those numbers are 4 and negative 4, and because my lead coefficient in front of the x squared is now 1, I can just put those numbers right into my factors. So x plus 4 and x minus 4. Okay, so let's go back and see. I have another trinomial where the lead coefficient is 1, so that's going to be the easy type of factoring where I have to find two numbers that multiply to negative 12 and they add to negative 4. So I like to start making a list of numbers that multiply to negative 12, like negative 12 times 1, or negative 6 times 2, or negative 4 times 3. And I look for the pair of numbers, if I added them instead of multiplying them, I would get negative 4. And that pair of numbers is this one right here, negative 6 and 2. So I found my numbers, and because my lead coefficient is 1, I can write them right in my factors. X minus 6, x plus 2. Alright, so let's go back to A, which is the hardest problem here. I have a lead coefficient of 3, so this is not the easy kind of factoring. Some people are pretty good at guessing and checking, and if you can find your factors without going through a lot of steps, that's fine, go ahead and do that. But if you need a procedure, if it's helpful, then here's one that works for me. I find two numbers that multiply to the product of A and C. So 2 times 3 is 6, so I need two numbers that multiply to 6. And when I add them, I would get my B term, which is negative 7. So the same two numbers add to negative 7. So thinking of numbers that multiply to 6, I think of 1 times 6 or 2 times 3. But the problem with these numbers is that they don't add to a negative. So the way you can solve that problem is by making both numbers negative. Negative times negative is still positive. But if I add them, now I get a negative number. So the numbers that multiply to 6 and add to negative 7 are negative 1 and negative 6. So I can't just put them right into my factors, it just doesn't work. But what I can do is split my middle term, negative 7x, into 2. So I'll have negative 1x and negative 6x. And then I need to bring 3x squared down and bring plus 2 down. So the only thing that has changed is I changed my negative 7x into a negative 1x and a negative 6x. Alright, now what I want to do is I want to split the four terms in half, and I want to take a greatest common factor out of the first pair. So in the first pair, my common factor is x. And that leaves me with 3x minus 1. In my second pair, negative 6x plus 2, I can see that they both divide by 2. However, because my lead term here is negative, I'm going to take out negative 2. And then negative 2 times 3x would give me that negative 6x, and negative 2 times negative 1 gives me the 2. So now, if the insides of my parentheses match, I'm on the right track for writing my factors. Because they match, one of my factors is going to be 3x minus 1. And 3x minus 1 is being multiplied by both x and by negative 2. So my other factor is x minus 2. Okay, in problem 2, to find the x-intercepts, and the hint here is by factoring, we need to think about our x-intercepts. When we have x-intercepts, the y value of those points, I don't know what that was, let's erase that. So the y value of those points is 0. So to find x-intercepts, you want to set your equation equal to 0. And then we're going to factor it. So the first one has a lead coefficient that's not 1. So what I'm going to do is the same steps I just did in problem 1a. I'm going to find two numbers that multiply to 3 times negative 20. So they're going to multiply to negative 60. And they're going to add to 7. So thinking of numbers that multiply to negative 60, I have negative 1 times 60, negative 2 times 30, negative 3 times 20, negative 4 times 15, negative 5 times 12, and I think I found the pair that adds to 7 right here. So I'm going to split the 7x into negative 5x plus 12x, and bring down 3x squared, and bring down minus 20. And then again, you want to split the terms in half. So you're thinking about the first half and the second half. In the first half, I have a common factor of x, so I take that out, and I'm left with 3x minus 5. In this second pair, they don't both have x, but they are both divisible by 4. That's the biggest number they're both divisible by. So I'm going to take out the 4. And 4 times 3x would give me the 12x, and 4 times negative 5 would give me negative 20. And now you can see the insides match. That's one of my factors, 3x minus 5. And 3x minus 5 is being multiplied by x and by 4. X plus 4. Alright, so to find the x-intercepts, we said that we need to set this equal to 0. So if I have two factors being multiplied and my answer is 0, one of those factors has to equal 0. So you set each one equal to 0. 3x minus 5 equals 0. X plus 4 equals 0. This one is a little longer. 3x equals 5 and divide by 3. So this one gives me x equals 5/3. This one's pretty quick, minus 4. So I get x equals 5/3 or x equals negative 4. Okay, in B, because my lead coefficient is 1, this is the easier type of factoring. I want two numbers that multiply to negative 14 and add to negative 5. So I'm going to list numbers that multiply to negative 14. I'm going to do negative 1 times 14, negative 2 times 7, and then I look at my list, and when I add them, I'm getting positive numbers instead of negative. So what you can do is you can flip the negative. It could be 1 times negative 14, or 2 times negative 7, and now I found the pair that adds to negative 5. And because my lead coefficient is 1, then I can do the quick kind of factoring, which is x plus 2, x minus 7. And remember, we said that it equals 0 because we're looking for the x-intercepts. The x-intercepts happen when the y is 0. So what you want to do is set each factor equal to 0. X plus 2 equals 0, or x minus 7 equals 0. This one, when you subtract 2, you get x equals negative 2, or in the second one, when you add 7, you get x equals 7. Okay, we're going to find solutions the same way. You can see that the equations equal, well, this one equals 0. And this one over here, we're going to make it equal 0 so that we can use our zero product property again. So let's start with the one that already equals 0. I have a common factor of x, so I'm going to take that out. X times x is x squared. X times minus 4 is minus 4x, and that equals 0. So if I multiply x times x minus 4 and 0 is my answer, one of these two things has to equal 0. Either x equals 0 or x minus 4 equals 0. So this one's solved. On the right, you can add 4 to both sides, and you get x equals 4. So either x equals 0 or x equals 4. Alright, going back to 3a, it doesn't equal 0 yet, so I can solve that problem by subtracting 9x on both sides. So this side is 0. I'd like this one to look like one of the quadratics I've been factoring, so I'm going to put the minus 9x in the middle. So it's x squared minus 9x plus 18. So to factor this, I need to find two numbers that multiply to 18 and add to negative 9. So let me list numbers that multiply to 18. 1 times 18, 2 times 9, 3 times 6, and I think I almost found it with 3 times 6, but I need them to add to negative 9. So what I can do is make both numbers negative. Negative times negative is still positive 18. Because my lead coefficient is 1, I can do the easy kind of factoring, where I write x minus 3 times x minus 6 equals 0, and then set each factor equal to 0. So this one, I'm going to add 3 and get x equals 3. This one I'm going to add 6 and get x equals 6. Alright, in 4 and 5, we're asked for the roots. The roots, let's see if we can find a different color. Okay. Alright, the roots and the solutions in this case, and also up here we found x-intercepts. These are all in the same place. They're all where the graph crosses the x-axis. And so the procedure to find them is the same. But in number 4 and 5, it's already drawn. So basically, we're just looking for those points here and here. So in number 4, our roots are at x equals, it looks like 1, 2, negative 3. And x equals 1. In problem 5, our roots are here and here. So x equals negative 6. And x equals negative 2. Okay, let's turn the page. And now we're graphing. I'm going to show you two ways to graph. I'm going to show you how to graph without a calculator, and I'm going to show you how to graph with a calculator. So the first one is in standard form. So if you have notes on standard form, you can pull those out and see the steps for graphing standard form. First thing you want to do is recognize A, B, and C. So your A is 2, your B is 4, and your C is 3. To find the axis of symmetry, you want to use the formula negative B divided by 2A. So negative B, that would be negative 4, divided by 2 times 2. Negative 4 divided by 4 is negative 1. So your axis of symmetry is a vertical line, so it's going to be x equals negative 1. To find your vertex, you're going to plug the x value of the vertex negative 1 back into the equation to find the y value. So the y value is 2 times negative 1 squared plus 4 times negative 1 plus 3. Negative 1 squared is positive 1, so we get 2 minus 4 plus 3, which is 1. So your vertex is an x-coordinate of negative 1 and a y-coordinate of 1. To find your y-intercept, the y-intercept happens on the y-axis, and everywhere on the y-axis the x is 0. So you need to substitute 0 for your x's. If you look, the first term has an x, so that whole term turns to 0. The second term has an x, that whole term turns to 0. The third term doesn't have an x, so this ends up being your y-intercept. So your y-intercept is 0, and then whatever your c value is. So in this case, it would be 0, 3. Okay, and then to do an additional point, we're going to use our a value, but let's look at the graph before we do that. So we know we have a vertex at -1, 1. And we have an axis of symmetry that goes through that right here. So normally, your parabola follows a pattern from the vertex. It would go over 1 and up 1, and it would go over 2 and up 4 on both sides. In this case, let's see, our a value is 2, so that's going to stretch all your y values by 2. So you would go over 1 and up 2 on both sides. And then if you had the room, you would go over 2 and up twice as much as 4, so you would go up 8 on both sides. So if there was room on this graph, you would make another point at 1, 9, because that would be going up 8. And you would have another point at -3, 9 as well. But we don't have space for that, so we're going to use these 3 points right now and graph that U-shaped parabola. Be careful to try to make it rounded. And for additional point, you could use either of these points. So I'm going to write that down. I have -2, 3 or 0, 3. It would probably be best not to use the y-intercept since you already stated that point, so the additional point would be best stated as -2, 3. Alright, in problem 7, this is now vertex form. So if you have notes on vertex form, you can take those out. It's called vertex form because the vertex is sitting right here in the equation. So the vertex, let's see, let's write down the form here. A times x minus h squared plus k. So because it says x minus h, the vertex is the opposite of this number and the same as this number. So let's see, our a is -2 and our h is -4, the opposite, and our k is 3. So the axis of symmetry is always going to be x equals because it's a vertical line, and it's going to be this -4, which is the x of your vertex. And your vertex is the h and the k, so that's -4, 3. So let's graph that vertex at -4, 3, and consider your a value. Your a value is -2. The negative means that the parabola is going to flip, so instead of opening up, it's going to open down. And then the 2 is a stretch. So we're going to go over 1 and down 2 on both sides. And then the normal parabola would go over 2 and up 4. We need to go down, and we need to go down twice as many, so it would be over 2 and down 8. So from 3, I think I can actually do that. I'm going to go down from 3, go down 8, and I will end up at -5. And then I'm going to go back and down 8 as well. So I have 5 points here. One of them I already used for the vertex, so I could list any of the other 4 for my additional points. Most people will probably try to just use the next 2 points here. So this would be -5, 1 and -3, 1. But if you cared to, you could add these points instead. And one thing I forgot to add here is the axis of symmetry, right down the middle. Okay, here's problem 8. In problem 8, we are using intercept form. And it's called intercept form because P and Q are the x-intercepts. So the formula is A times x. Oops, that's not an x. x minus p times x minus q. And p and q are the x-intercepts. So the a value is 1/2. The p value is the opposite of this number, and the q value is the opposite of this number. So the p is -3 and the q is +1. So that means that we have x-intercepts at -3 and at +1. To find your axis of symmetry, it's halfway between these. So halfway between -3 and 1, I'm going to move in one box, I'm going to move in one box, and then let's see, move one more. So my axis of symmetry is at x equals -1. The vertex will have an x value of -1, and to find the y value, you can plug into your equation. So I'm going to do y equals 1/2 -1 plus 3 times -1 minus 1, which is 1/2 times 2 times -2, which gives me -2. So my vertex has an x value of -1 and a y value of -2. -1, -2. Okay. The intercepts we already said are at -3 and at 1, and you want to write them as points. So you have -3, 0, and you have 1, 0. And you can graph through the vertex and through those points. Oops. Okay, I'm going to finish this page up, and then I'm going to go back and see if I can show you how to do these problems as calculator problems as well. So if you were waiting for the calculator work, just be patient. Let me finish up 9 and 10, and then we'll go back and do the graphing problems as calculator problems. So in 9, to write the equations in standard form, you basically need to multiply them. So I would start by multiplying binomial times binomial, this one times this one, and then at the end distribute the two. So I have y equals 2, and I have x times x, which is x squared, x times -6, -3 times x, -3 times -6. Okay, combine your like terms, -6x and -3x. So I have y equals 2, x squared minus 9x plus 18. And then distribute the 2 to all three terms. So I have y equals 2x squared minus 18x plus 36. In B, you have the square of a binomial, so when you see that, remember that you have to multiply it by itself. It doesn't work to square each term. So you need to write x minus 2 times x minus 2 and plus 7. So let's ignore the 1/4 and the 7 for a moment and multiply the binomials. X times x is x squared, x times -2, -2 times x, -2 times -2. Combine your like terms, so I have y equals 1/4 x squared minus 4x plus 4 and plus 7, and distribute. So 1/4 x squared minus x plus 1 plus 7. And then combine your plus 1 plus 7. So y equals 1/4 x squared minus x and plus 8. Okay, let's go back, if you like, and look at how to do some of the graphing problems with a calculator. If you prefer to do it by hand, that's fine if you feel comfortable with that, but if you have any doubts, it's good to have the calculator as the backup. So let's look at problem 6. I think that was the first graphing problem. So we're going to graph 2x squared plus 4x plus 3 on the calculator. So here it is. Let's move it into the screen. Okay. So you want to press y equals and type in 2x squared plus 4x plus 3. And you're going to graph that. So press the graph button over here. Now if your window looks weird, you can try hitting zoom standard, which is 6, and that might fix your window. Okay, so we're looking at this now, and you're trying to figure out, well, what are these points that I need to plot? You can see the important points are happening around -3, -2, -1, 0, so you can get those points from the table of values. If you press second graph, here's the table of values, and I can see 19 is too big for my graph, so I would graph -3,9, -2,3, -1,1, 0, 3, 1, 9. I would graph all of those on my graph. Once you have those on your graph, let's see if I can move this out of the way. Nope. So once you have those on your graph, then you can look at your graph and determine your axis of symmetry, your vertex, your y-intercept, and all of that. Okay, now let's look at the equation that's in vertex form. Again, we can type it in exactly as we see it. So let's see if I can move this someplace where we can see it. Go back to y equals and clear out what you have and enter the -2. I'm going to need to raise this higher to see the negative. It's -2 parentheses x plus 4. Close the parentheses, and then this one is going to give you the squared and plus 3. So we graph it, and looking at the graph you can see that the important points seem to be over here. -1, 2, 3, 4, 5. So you definitely want the points around -5, -4, -3, and maybe a few extras. Look at the table of values, second table. Try again. Second table. And you can get those numbers here, and then you plot them on your graph. After you plot them on the graph, you can tell where your vertex is and where your additional points would be. If you can't see enough points on the screen, you can go back to find more points. In problem 8, we're in vertex form, no, we're in intercept form, but again, we can put this in our calculator. So 1/2 is a fraction. Let's see if we can raise this up here. So we need parentheses around your fraction, 1/2, and then we want parentheses x plus 3, x plus 3, parentheses x minus 1. And close parentheses. Oops. And it looks like I neglected a minus. So let's do second, insert. Nope, it's not there. Second, insert, and that was supposed to actually be a plus. And let's graph. Oops, I forgot something else too. So that should be -1. And close parentheses. So graph that. Now you can see, just like we expected, if you have +3, that gives you an x-intercept at -3. If you have -1, that gives you an intercept at +1. You can probably tell your vertex from the graph. It looks like the coordinates are -1, and then you could look at your table of value to find that the y-coordinate is -2. But if you can't tell from the graph, there's one more method you can use. Let's graph it, and we can calculate the minimum value here. So you can press second, and calculate is above the trace, and we wanted that minimum value, which is 3. It asks you to go to the left of the minimum, so you move to the left of the minimum, press enter, and it asks you to go to the right of the minimum. So you go to the right of the minimum and press enter, and it asks you to guess, so you just move close to the minimum and press enter, and then it gives you the exact coordinates. This -0.99999 is a rounding error. It is actually -1, but the -2 shows up for your y value. Okay, so that's the end of pages 1 through 3, and there's another video for pages 4 through 6.